What are all of these diagrams and charts, you might be wondering? To be honest, I have no idea. These are screenshots I took from the tensor board application that was available while I was running local training using MeloTTS. I forked the MeloTTS repository, made changes to the code so that the training can be run on Windows. All of the installation steps are available in text form on the GitHub page. And all of the steps and details for doing the local training are also available on the GitHub page. I will link to that. You will first need two things, Miniconda and Git for Windows. Download and install these. I will leave the links. Create a folder where you will install Melo. I am going to create a folder on the C drive. CD to that folder from a conda prompt. Do a git clone of the fork repository. CD into the newly created folder. Create a new conda environment using the YML file. Activate the newly created environment. Install MeloTTS using this command. Download one of the required dictionaries. And install PyTorch. And now you can launch the web UI. Here I added another dropdown where you can select the checkpoint file for a custom trained voice. Right now this dropdown is empty. Later in this video, we will see how we can add our custom trained voice to this dropdown. I also fixed the issue where the downloaded file from here wouldn't have a wave extension. For now, let's close this web UI and stop the server by pressing Ctrl+C. Let's do training. First, you will want to CD into the Melo directory. This is located in the root directory where you did the git clone. Now let's go into the data and then example folder to delete the existing sample list file. You can take a look at it before deleting just to see what the transcribed text should look like. Once ready, delete this file. The audio files I have are MP3, and the training requires WAV, so we will need to convert them. To do that, create a folder called MP3. Place all the MP3 files you need converted in this folder. For this demo, I only have 5. You will want at least 5 files, otherwise you will get an error as less than 5 is not enough. The mask is still visible, but not as ideally, you would have a lot more. I went ahead and ran our favorite audio. Anyways, let's get started with. There are 3 prerequisites. We can see the face mask box, and now these are 5 very short audio clips. Nowhere near enough for good training, but for this demo, it should suffice. In the Melo folder, there is a batch file called Convert MP3 to WAV. If you open it with a text editor, you can see the input and output folder paths. Change these if you selected a different folder for your files, but I will leave this as is. Run that batch command from within the conda prompt. Now if we go to that folder where we had the MP3 folder, there should now be a WAV folder with the converted WAV files that we can use for training. The mask is still visible, but not. Now if we go back to the Melo folder and open the transcript Python file with the text editor, we can see the input and out file names here. I am going to leave these as is because that is the right path for the waves. You can also change the language code and language model. I still need to experiment with different values to see what provides the best results for this particular voice. Let's run this Python script from our conda prompt to transcribe the audio into a list file in the format that is required by MeloTTS training. Now we can go to that folder and see the list file that it generated. And here are the transcribed texts for the 5 audio files. Great. Now we must run a preprocessing Python script to create some more training files before we can start the training. Here is the name of the script and the input parameters. All of these are in text form on the GitHub page. Let's go ahead and run the script in our conda prompt. Oops, Windows is asking me how I want to edit the Python file. I forgot to include the Python command before the file name. When this finishes executing, we will see a lot more files in that data example folder got created. One of the new files is the config.json file. We can edit values in this file to control the training with things like epochs, learning rate, batch size, and so forth. Make changes here that you want. You may need to experiment to see what works best for you. I am going to increase the batch size. If we go back to the Melo folder, there is a train batch file. We can open it with a text editor. Make sure the path is correct to where the config JSON is located. I am going to leave it as is, since I didn't make any change where the files are located relative to what I set these paths to by default. Now we can go to the counter prompt and run the train batch file, and that is it. It will start the training. For the settings I am using, which are the defaults with the exception of batch size, it created a new checkpoint file every 15 minutes or so. Eventually you will start to see the output look like this. This outputs the status after every epoch. You can let this run for as long as you like. There is a Python inference script you can run on the checkpoints, and once you have a checkpoint you like, you can stop the training with Ctrl-C. If you go to the data example folder, now you will see there is a new folder called config, and this config folder has all the training things like logs and checkpoints. Currently we just have the step 0 checkpoint, the G_0, so it won't sound like the voice from the WAV files, but for the purposes of this demo, we can give it a try by running the inference using that checkpoint. I am going to replace the text with some text. For the path, this is the G_0, so I will change that. I will just copy-paste the folder path and then change the file name. For the output, I will call it output. And now we can run this command, but our counter prompt is currently busy with training, so we will need to open a second counter prompt, cd to the Melo folder in case we want to run some other script, then activate the environment, and then we can run the command.
Why is there so much dead silence? I guess since he's not saying anything, I will begin talking about ducks while you watch the video. Here's an interesting fact about ducks. Ducks have a unique feature called a nictitating membrane, a translucent third eyelid that acts like goggles underwater. This membrane allows ducks to see clearly while swimming and diving, protecting their eyes from debris and water while still letting in enough light to navigate effectively. I wonder what happened to the host of our video. I think he might have fallen asleep in the middle of a sentence. Oh well, I will be taking over from here. This inference command is going to take a while on the first run, I believe. It looks like it is now done. Let's go over to the output folder and have a listen.
Some text here.
That sounds like it was the pre-trained voice being used for the training. I think we'd better wait for the next checkpoint before testing it. While we wait for the next checkpoint, we can launch the TensorBoard. First, we will need to install TensorFlow. With that done, we can launch TensorBoard with this command. The log URL is the config folder where the checkpoint and training logs are stored. Let's run it.
Sorry about that, I am back.
What happened? Are you okay?
Yes, I am fine,
He fell asleep again in the middle of his sentence. Anyways, TensorBoard is now running. We can go to it from this URL. And here is the TensorBoard with all the details. Here is where the screenshots are from that were shown in the beginning of the video.
This is all wrong. I shouldn't be up here. I should be back in school, on the other side of the ocean.
He is talking in his sleep. Anyways, there is a lot of information available to see here on TensorBoard. After some time, we have our second checkpoint, after 1000 steps. In a third counter prompt, let's run inference using the new checkpoint. It is done. Let's have a listen.
Some text here.
That was like 2 words, but the voice is starting to take shape. We could run inference with a longer sentence. But first, let's set it up so we can do this through the UI. Go to the Melo folder and create a new folder called Custom. And in this folder, we want to place the checkpoint file and the config JSON file. We can rename the checkpoint file to be a more user-friendly name. And now we can launch the UI. Let's scroll down and select the custom checkpoint file. Now when we click Synthesize, It will use that checkpoint file for the voice.
The field of text-to-speech has seen rapid development recently.
Well, that sounded interesting. I think you would like that. But I want to try out a different prompt.
This is all wrong. A Sultan be up here, a set be back in school, on the other side of the ocean.
Well, that sounds very interesting. You can download the file by clicking this icon. If you open the train log file, you can see the text log output during the training with information about EPOS and such. Well, that is about it. This ended up being a very long video. Anyways, all of the commands and steps are listed also on GitHub. When you want to end the training, you can Ctrl+C on this counter prompt to end training.
I am back. Sorry about that. Anyways, where were we? We can start up a TensorBoard to see the progress of the training. Let's take a look at how we can do that. First, we need to do a pip install.
And he fell asleep again. Well, we should probably end the video now before he wakes up again and starts all over from the beginning of the install. That is all for now. Enjoy.